Hello everyone, my name is Permal Jagan and I'm so happy to be back. And today we are going to continue what we were doing. Okay, we are going to do the malware analysis, the Golang malware analysis that we are up against. And we already did few things. We used tools like Floss, Kappa, and PE Studio to analyze its portable executable headers and uh, its imports, the syscalls that the Windows AP calls that it has been importing, and also we used FOSS and Kappa to reduce the behavior of the binary. Okay, now what we are going to do, we are going to do some disassembling. We are going to use Ghidra, tools like Ghidra to disassemble both the binaries. So you know very well we are actually up against two binaries, and you can see here this particular binary is the main one, MC ModMaker version 1.4.exe and GoTeam.txt. So this is appears to be the ransomware binary, and here is the ransomware node. We have already seen this. Fine. Now it looks like the decryptor bruh.exe. It's the decryptor. It is given. So all we need to do is to disassemble this binary and find the uh, key of decryption. So that's the aim. Uh, in my previous parts, I've struggled a lot to disassemble or reverse this Golang binary, but hopefully I actually did some work, and I'll be able to come over that. Let's see. Okay, I hope you guys can see the screen. Fine. Now I have installed few tools actually. I reverted the VM state to the fresh one, and I installed tools like Commander. So hopefully it's gonna help me to use some Linux oriented commands over Windows to list the directories and all. All right, now what I can do, I actually need to do some uh, this reversing disassembly, right? Okay, first of all, let's see what are the questions we've already answered. Right from the start, based on incident history, the text file contains the extension append. Okay, actually we read the file d.txt, and it revealed it was actually a ransomware. So that's what we've answered. And what mechanism does MC ModMaker version 1.4.exe use to send information back to C2 server? And it was webhook. Let me prove that. Previously I was not handling the Ghidra properly. I was quite struggling because it's been a long time since I've used it, so I struggled a lot. But now I guess I got a clarity. Let's see. I need to go to desktop. Inside the desktop, advanced static analysis, Ghidra, and I'm starting the Ghidra utility. Inside Ghidra, I have already loaded the binary that I need. So I'm simply going to open that and analyze. Okay. When I was doing the work, I did load the second binary as well. But now I guess it is time to assess the first binary. Okay, let's see. Open. Yes, so I actually opened this ModMaker version 1.4.exe. So here is the program tree and symbol tree that loads the import, export, some namespaces symbol. Usually what we do, we go to functions if it is a C or C++ binary and check for the main function. But in Golang binary, fine, analysis found in the symbol entry. Would you like to go to that symbol? No. Okay. Now, actually, as I said, in C and C++, we check for the functions, the main functions inside the functions directory. But here in Golang, we should go to namespaces. If you go to namespaces, when you scroll down, you would find a place called main. So this is what holding the main function. If you see, here is the main function. So I'm clicking this main function, and you can see the main function is opened in the decompiled view and also the disassembled view. This is the disassembly view. This is the decompiled view. Now I'm simply scrolling down. I hope my picture is not hiding. I'll try to keep important things in this place. Okay, now I'm scrolling down. If I scroll down further, I could see a function called run command. Then if I scroll down further, I could see a function called main.send to discord. So looks like this is the function that actually trying to reach a discord server. Maybe it would be trying to use discord as a C2, but I don't know. Looks like here you can see discord API, it's been it's been trying to reach, and I could see the webhooks. So let's see what is webhook. So just a learning here. Um, what is Discord webhook in malware analysis? A Discord webhook is a unique URL that allows automated messages and data to be sent to a specific channel via in a Discord server. In malware analysis, attackers often exploit Discord webhook to communicate with a compromised system, sending stolen data and receiving from commands. Okay. Looks like it's a unique URL that allows kind of opening a unique channel for C2 communication. I think that's what the Discord or the concept of webhook is all about. Uh, Fine. Let me go to the malware VM, and here is the answer. So in this particular URL, it clearly says it is webhook. So that was the answer. We already did answer to the question. It was the second question. Now let's see the next one. What command does modmaker version 1.4.exe run suggesting? It means to execute other binaries or scripts. So they say the MC modmaker is also suggesting to execute, suggesting that it means to execute other binaries. Okay. So they are actually asking us to find the command that is actually executed by this executable. That command actually has the capability to run the other scripts and binaries. Now I go here. We have seen the run command function call, right? So let me take that. Here is the run command. So I'm just clicking that run command, getting into that subroutine, getting into that function definition. And here, if I see with my bare eyes, I do not see any interesting comments, because we usually see these things in comments, like here, the commands that you use to execute, but if it is added. But here, I don't see any command that has the capability to run binaries or scripts. But how I can find this? Maybe I can use a dynamic analysis. I can use some uh, uh, debugging tools to analyze it. So this is where actually when I was struggled, I did refer some write-ups, and let me open that write-ups. I'm not shy to open and show these write-ups to you. So let's learn together. That's the important at the end. Mail, mod, malevolent mod maker write-up. The official write-up was actually not giving me the information that I want. Let me tell you this, how I'm actually telling this. Malware analysis, malevolent mod maker. Come on. Yeah. Malevolent mod maker. And here, if I open document.pdf, here if I scroll down further to answer the third question, you can see they are also referring the same run command, which is part of the main function. And also the malware uses curl command to retrieve the ransomware binary, presumably send the data back to API. Actually, we have seen that in our previous parts when we were analyzing the strings. There were some couple of curl command usage. But now here you can see some comments. I don't know which window it is, but hopefully from another write-up, I got to know this is actually came from debugger, x64 debugger. And you can see the list of comments here, and this is the answer. This is going to be the answer. But the point here is how we are going to find this ourselves. So that's what I'm just trying to do right now. Let's see how I can achieve this. I was actually about to open a write-up, right? So let me go to my browser. Yes, I think this one. So here are some write-ups. Malevolent mod maker, Golang based ransomware, dynamic binary analysis using x64dbg. This is what we are about to do right now. And static binary analysis using Ghidra and detected TC. We have used detected TC already. Now go to this write-up, and here is the MD5 file. So let's go here. So we already did all these parts. So we found it's Golang binary and we opened this file. The second question is webhook. Actually, we have spotted that this webhook part as well by using our Ghidra disassembler. Now the third question is this one. And the answer is this one, but how to find that? To identify which commands were used to execute the binaries, I manually debug the sample using x64, passing the execution just before the webhook was called. The simplest approach is to search for error strings and any other strings of interest. Okay, I haven't used x64dbg on the stream. Maybe this is going to be an interesting stuff. Now, if you see, they inspect the offset from, we identify this particular command. So when they were investigating on x64dbg, they found this part. All right, without further ado, let's go. I go to this lab. I'm launching x64dbg, which is already installed here, and I'm opening the file. Let's go to mod maker, malevolent mod maker, danger, mod maker version 1.4.exe. Opening it. System breakpoint reached. So whenever you load an executable file, it hits the system breakpoint, stops at the beginning. Now it is our role to put a breakpoint in a specific spot. Okay, so that's what we need to do. Maybe I'm just I've never used. It's been a while since I used this, so I might be struggling. So bear with this. Let's see. So it's an incredible tool actually to use. I go to options first of all to just maximize the appearance. Font. Maybe how about using 12? 12 looks okay. Yeah, 12 looks okay, right? I think it is clear enough now. Or maybe 14. 14 is little more better. All right, so I'm just making it 14. 14, 14, 14. This font is fine. Okay, now I tried maximizing it. Now I can see this even clearly. Comments are command separated, move AAC EBX. So let's learn this x64 reversing, debugging to be frank. So let's see what are all the steps to follow before we how to apply the breakpoint and execute, and how to how to do the step-by-step execution. Or let's see all these things. x64dbg cheat sheet maybe. Can I get the resource? Yeah, shortcut or cheat sheets. So here is the command page. Command argument, argument to argument, and okay, general purpose command. Yes, so here it is. File, open, attach, detach, exit. So now this is fine. Actions, find command, find in current mode, find strings in current module, go to previous reference, next reference. This is fine. Breakpoint. So here is the stuff. Toggle breakpoint, conditional breakpoint, toggle bookmark, delete breakpoint. So F2 is to apply breakpoint. But before that, I should stop at main function. How I can stop at the main function? Let's see. So this one is actually run. This one is actually pause. This one is actually close. Step into, step over, trace into, trace over, execute till return, run to user code, Scylla, patches, comments. It's a powerful utility. If you learn this, then you'll be able to uncover plenty of things. But settings saved is okay. I'm getting a message. But how I can get into the main function? How to search them? Let's see. Control F if I press main. Can I go to main? No. I don't want to execute this fully. So when the program opens, it actually stops at the entry point, I guess. Um, let's go and read this. Running F9, run until selection, pause, restart, step into. Restart is actually Control F2. Control F2 or like this. Yes, now I have restarted this. Now you can see I'm actually at some point. I'm at this particular address. Let's see. This cheat sheet would be very helpful, but let's start from the scratch. Um, After loading exe file, how to jump to specific function, or how to apply breakpoint in main function. Using the symbol span recommended. Load exe, okay. Wait for the analysis. x64dbg pause the system entry point, okay. Wait for the initial analysis to complete. Navigate to symbols tab in the lower left pane. Left lower. View symbol info. Yeah, there it is. So this is the CPU view, and symbol view is actually not here, but when I click symbol view, I could see them clearly. Symbol info is not yet loaded. Party is user, so it is relying on these DLLs. Okay, now let me take a screenshot of it. Um, Copy this to clipboard. I go to this. I go to AI. Um, how to run this? Maybe if I run, what happens? Let's see. Um, if I run, debugging stopped or terminated. Did I infected the machine? I guess I did infected the machine. I just messed with the machine. But not a problem. I guess this one is still sandbox, right? Isolated one, not connected to internet, so no problem. Um, Maybe what I can do is to reopen the file modmaker.exe. Okay, I have loaded them. Command BP. I should put the breakpoint in a main function, but how I can find them? Um, Typical pause at the system entry point, waiting for the initialize to complete, indicated by the status bar at the bottom. Navigate to the symbol, look for the name of the executable file in the list, expand it, search the symbol main or winmain. Okay, I think I should click this from symbols entry. I should go and click them. Uh, Symbol info. Come on. Gosh. I go to symbol info again. And if I just click this symbol, this particular binary, when I scroll down, I could see a bunch of imports and exports, but where is the main function? Huh. So let me check this out. Tracing plugins. Symbol info. modmaker.exe. Address of the entry point 840 So this is where it is. Yes. And let's see plenty of things here. A lot of functions getting imported from kernel 32. But how to find like where to stop? Like where is the main function? How I can find them? Uh, Let me go and search here. So this is the symbols pane, right? Can I go and take a screenshot of it? I go and get the help from ChatGPT now. Not gonna hesitate because I'm learning now. ChatGPT. Stay signed out. I am learning malware debugging with x64dbg. How to I open the binary. Now how to do I have any text file here? No, not here. Inside the infected VM. Do I have any text file in this directory? Come on. Sample mod maker. Mod maker danger.txt. Since I have executed the binary, I wanted to check whether any files got encrypted now. Okay, now I go and do this ChatGPT query. I'm learning, I opened binary, then how to get to main Golang binary to main function or apply breakpoint in main function. Go binaries are very different from C or C++. So usual main breakpoint workflow doesn't work out of the box. They walk through how reliably reach go main.main xdbg. Okay, I think, let's see. In PE entry point, is not main.main. Executable flow is roughly entry point, runtime. So runtime.main, then main.main. This is what you want. So if breakpoint at the entry point, you are far away from go main. So that's what. And let's let the program run until go runtime is mapped. You pass the system breakpoint, good. Press F9 once or twice until the program actually starts running go code. Then pause again. What? Control F2 or pause button. Okay. F12 or pause button. Find Go runtime symbols even without PDB. Go windows usually contain their own symbol names. Go symbols tab. Alt tab. Search for runtime main and main.main. Okay, if you see runtime.main, right click breakpoint toggle. Manually locate main.main via strings, very reliable. So let's see this one. Search current module string. Okay, let's see. Search current module string. Can I see them? Modules. Can I see anything? No. How about strings? We already reached the 28-minute mark, but I'll try to just fix this. How to go to strings here? I think first we need to run the binary. Still it is in the system breakpoint. First we need to run. For that, F9 one or twice, the program actually starts running go code. Then pause. Okay. F9 to run the program. Then pause. I should press this one. Okay. F9. Come on. F9. No, it's not working. F9 if I press. Okay. Now what happens? Look at this. Here it got changed. So the F9 is the part. I did press F9. What happened? Actually, it ran like pressing this one. Now you can see the breakpoint entry point at address of entry point. Okay. Now it is actually at this particular spot. Now if I go to a CPU view. I do not see. Okay, let's see now. Again, I'm going to symbol stable. I'm still seeing the same. Okay, let's see. I'll just paste this screenshot as well to ask a question to ChatGPT. Let's see what happens. Yeah. Copy clipboard. Copy to clipboard. Now let me go and paste this one. Ghidra with Go plugin, Hida with Golang loader, before mainly runtime behavior and API tracing. You're currently paused at the PE entry point of Go binary. So that's what it means. So earlier it was actually at the system breakpoint. Now it paused at the PE entry point of Go binary, which is expected. Now we walk from here from Go, sorry. Now we walk from here to Go Go's main.main. I'll give you exact the concept that you are. Okay, let's see. You are passed at optional header address of entry point. This is not main.main. Okay. Now we are at the binaries entry point. This is Go's low level startup stub and eventually calls. So it's gonna call this one and this one and this one eventually. So get to main.main step by step. How to do that? Double click. You should already be there. Just be in the case. Double click optional header. You will see disassembly instruction now. Really. If I click this, yeah. Now, yes, 840C0. So this is the entry point, and here is the disassembly of it. And now, I guess I am in that entry point. Then, from this exact paused state, press F9 to run once. Let it run. If it pauses again, quickly TLS loader breakpoint, press F9 again. Don't single step yet. Go to startup code. This is huge and slow step. Okay, I think I need to run it again. So let me do this. I run once again. It says debugging stopped. So I reached the entry point, but when I ran again, I completely did the execution. So the debugging is right now, it's stopped. So how I can restart it? Maybe I can go and open this recent file once again. System breakpoint is reached. Run this once. Now the breakpoint is reached. So here's the the entry point. So it stopped at the entry point right now. If I go to symbol stable, do I see anything, any interesting info? Let me go to symbol stable. Can I see any stuff? I'm still seeing this binary and its imports, but handles, threads, CPU, address of entry point is totally fine. Can I search for the strings now? Since the binary is loaded now. How to view the strings? I need to know the address of the particular main function. If I know that, then it's going to be a piece of cake to apply the breakpoint there. Then resume execution. Come on. Okay. Now let's go. Search strings. Search current module string. So this is the label stuff. Let's see. Search current module string. Where is the search table? Current module string. to do string search here. So we already crossed the timeline, the time mark, but anyway, let's see. You are on the CPU view, exactly how to string search in x64, but you are okay. Right click anywhere, the CPU disassembly view, search for current module and the string. Okay. Search for current module. Yes, search for current module, string references. String references. Yeah, here it is. So this is what I was looking for. And here I should search main.main. Come on. But I'm not seeing this one. But this is the string, right? Now what I can do, maybe, how about searching Discord? Discord, can I see them? Go to not search for all modules, string references. Okay, sorry, main.main. Can I see them? No. Or simply main? No. Okay, how about running the step one by one? Step over. So it is running one by one, the instruction one by one. It's quite hard to adapt to this DBG. I have used GDB, but not X8, x64 often. Current region command, constant string references, pattern, GUID. String references. Here are the strings, but what if I search curl? Can I see curl? And if I check for curl, you can see there are two instances. So it literally says the. So here are the addresses. So it is actually trying to access one URL with HTTPS. You need .htv API v2 country city VPN. So looks like it is using this particular API. I think we are answering one question here. So let's answer this question and move on. I'm go and scroll down here. There is a question. Come on. Yes. What is the value of the API key contained within the URL, which suggests it to enumerate the geolocation data? And here is the, come on. Yeah. Here is the URL. You need .htb API v2 country city API key. And here is the URL and this is the API key. So I guess I clicked it. Now I'm in that instruction. If I just scroll this side, yes, I think I got it. I think based on the string search, if you go, I think it works in x64dbg. Now you can see we have reached the place that we want. I did not go via main function, but here is the thing. And here the command, here this is the URL and the API key is given here. Copy selection. Yeah. Now if I try to paste them somewhere, what I get? It actually copied the whole string, but this is the API key that I need. So I go and answer this, and that's the TLS. I think I should ignore this TLS at the end. This is the right answer. And what command does IMSI BondMaker run, suggesting that it may to execute other binaries or scripts? And it's actually here. Save. Okay, and you can see this one. PowerShell execute. PowerShell EP bypass. So this is the command that is used to run the other scripts. And also you can see followed by this command, it tried to execute this goteam.txt as well. Yeah. So I copy this value as well. Copy selection. Come on. In this, I need this part only. PowerShell-EP execution policy bypass. I go here and put this. That's going to be the answer. And now, what domain the C2 server serves the ransomware? What domain is the C2 server that serves the ransomware payload? Let's see. It's going to be here. Here it is, and you can see this. So followed by this particular curl command, curl http :/goteam.stb : 8080 goteam.exe. Seems this is what's serving the goteam.exe binary. We've already checked in VirusTotal. This is the ransomware binary, so it's obvious. So this is the domain name, goteam.stb. How about that? goteam.stb. So they asked the domain of the C2 server, and this is the answer, goteam.txt. So okay, now so far we have answered 5 questions. We yet to answer 6 more questions. I think we are already over the mark. We are at the 45-minute mark. So I'm stopping here. I'm going to continue this analysis in the next part.